Now that we've discussed the probability density function, which we use for visualization of continuous distributions, and the cumulative density function, which we use to calculate probabilities, we're going to go over the uniform continuous distribution, which is denoted as x followed by a tilde, indicating that x is a random variable. The capital U denotes the uniform distribution with its arguments a and b being the minimum and the maximum. So the continuous uniform distribution describes random outcomes that are symmetrically distributed around the mean, mu, with all outcomes between the minimum, which we denote by A, and the maximum, which we denote by B, being equally likely. So all outcomes over the range A to B are equally likely to occur. As I previously noted, we indicate that x is a random variable that is distributed uniformly over the range A to B by x followed by a tilde to indicate that x is a random variable that is distributed with a capital U to indicate uniform, with the arguments being A, the minimum, and B, the maximum. And the mean of this distribution, mu, is simply going to be the midpoint, A plus B divided by 2. The PDF, lowercase f of x, equals 1 over b minus a, or 1 over the range. So the probability 1 that something occurs is just distributed uniformly over the range b minus a, which looks like a rectangle that has a height of 1 over b minus a. The CDF, or capital F of x, equals x minus a divided by b minus a, or the value x minus the minimum divided by the range. The CDF looks like a straight and diagonal line that starts at 0 at the point A and reaches 1 at the point B. Again, the mean for this distribution is simply the midpoint between A and B, or A plus B divided by 2. And because this distribution is symmetric, we have 50% of the distribution below that mean and 50% of the distribution above that mean. Along with being a practical way to introduce the concepts of the PDF and the CDF, the uniform distribution is also useful for what-if scenario analysis when you're trying to account for uncertainty. Now, returning to the 3 types of events that we look at with continuous distributions, let's take an example where we assume that our random variable x is distributed uniformly over the range 50 to 100. So the PDF for this distribution, f of x, is going to equal 1 over 100 minus 50, or 1 over 50. And the CDF, capital F of x, is going to equal x minus 50 over 100 minus 50, which is equal to x minus 50 over 50. And the mean for this distribution is going to be the midpoint between 50 and 100, which is equal to 75. So here we see a graphical representation of the PDF. The height is 1 over 50, or 0.02, over the range 50 to 100. So the first type of event that we're going to consider is the chances of our random variable x being less than some value. In this example, we're going to calculate the probability that x is less than 85, which is just equal to the CDF, capital F, evaluated at 85. We can see this is just equal to 85 minus 50 divided by 50, or in other words, 70%. The second type of event that we analyze with continuous distributions is the probability that x is greater than some value. In this example, we're going to calculate the probability that x is greater than 60. This is equal to 1 minus the CDF evaluated at 60. Since the CDF is going to give us the probability of getting less than 60, subtracting that from 1 will give us the probability of getting greater than 60. So we see that this is just equal to 1 minus 60 minus 50 over the range of 50, or in other words, 80%. And then lastly, the third type of event that we look at is the probability that x falls between two values. In this example, we're going to calculate the probability that x falls between 60 and 85. To do this, we're going to first calculate the probability of getting less than 85, which is just capital F evaluated at 85, and subtract from that the chances of getting less than 60, capital F evaluated at 60. So in the first case, we see the chances of getting less than 85, or 85 minus 50 over 50, is going to be this entire blue shaded region. And then we're going to subtract this red shaded region, which is the chance of getting less than 60, which will give us the remaining 50% that we see here. So those are the three types of probabilities and how they are calculated using the continuous uniform distribution. In the next video, we're going to cover normal distributions.